Is it back? All right. So the company has a stock of zucchini. Now, are the units the same? Yeah, kilograms and kilograms. So 16,200. Broccoli, carrots, and cauliflower. There. And again, you wouldn't want to solve this using elimination because it would be really confusing. Then that's why we have a better method. So we're going to write this down. Now, if there's 0, so we just don't list those. So like for this zucchini line, we'll have 0.3x1 plus 0.2x3 equals 16,200. Does that make sense? The broccoli is in all of them, so I don't love the subscripts. I found them more confusing looking, but I'm probably not going to use them again. I just wanted to show you. There's no X4 in that one. And I would have probably lined the equations up with the X's under the X's if I was going to solve it. And I would just leave spaces, just so it was a little easier to read, but we're not going to solve it. We're just setting it up. So. Now, you could just multiply all of these equations by 10. Right? It would add a 0 to the end, but all of those numbers would be 2s, 3s, 5s, 4s. It'd be easier to work with than 0.2s, right? If you multiplied everything by 10, it would move all the decimals over. If I were going to solve it, I'd probably just do that first so that there was no decimals. Does that make sense? Not necessary.
Like little picograms or something?
Yeah, whatever the one unit bigger is.
Just like
it wouldn't change it.
King Henry, whatever.
Yeah, it wouldn't change it, but
it would go the other way. I don't know what the other way is.
They would still be kilograms, but yeah, you wouldn't have to change the answers, no, because you can disguise an equation by multiplying it by anything. It's still the same answer will work. So, yeah, yeah. But if you're just reading the last number, then that's what you're thinking. Like this wouldn't be it wouldn't represent the kilograms, that number, but the answers would still work out. Yeah. My goodness, it's hot in here. Okay, so what's the time? So let's go a little bit. We'll start solving, showing you how to solve a little bit. So what we're going to do is what's called so it's still elimination, Gaussian or Gauss-Jordan. There's two different types of elimination. I actually use Gauss-Jordan elimination exclusively, like always, but some other professors use Gaussian. So I'm going to tell you what the difference is, but...
Gaussian, is that a filter too? Gaussian filter?
Yeah, it probably is this exact...
equation?
Well, it would be like, because you're weeding out, like you're eliminating things, so it's... Yeah. So if there's something called that, then it probably uses it.
I'll have to look it up and see, but I feel like that's the same thing.
Yeah, it's probably based on the same thing. You probably narrow things down until you get the answer, right?
Yeah, it was talking about like visual fields, and then how like you apply a Gaussian filter to it, and it makes it like there's less lines or whatever. So
yeah, so that would be, yeah.
You can't see very well. Once you apply the filter to it, you can see outlines.
Right.
Yeah.
Yeah, so that's probably exactly what they're using is something like this, yeah. Yep. This probably is hyphenated. All right. So what we do basically is we write the, sort of like the table, we're going to write the equations into a matrix. So it'll actually just look like the table again. We're not going to start with that big one. Let's look at the other one that we did with 3 in it. So let's write this down. 2x plus 5y 5z. So you've got a system you want to solve that has more than 2 variables. So step 1 is to put it into what we call an augmented matrix. So step 1, write the system as an augmented matrix. So augmented in math means like put together or shoved together. So I'll just show you what this means. So you just put a square bracket. Matrices always have square brackets. And then you just list the numbers across 2, 5, 5, 360. 2, 5, 5, 360. And then the next equation. And the last one. Okay, so it has brackets, and then a line here. Sometimes they show that as a dotted line in some books or a solid line, but I just put it as a green line. That's the augmented part. You're putting the coefficients of the variables in the same matrix as the answers. So that's what the augmented means, put it all together. For our purposes, it really doesn't matter, but putting the line there, it's like the equal sign, right? So that you can remember. Okay, and then what we're going to do is elimination, which is kind of like what we just did, multiply a row by something and then add it together to make zeros, basically, which would mean it's eliminated, right? So what we are going to do are called row operations. So step 2, we are going to perform row operations that will eliminate all but one of each variable. And then we'll be able to read off the answer. So I'm going to show you what those row operations are. Sounds easy, but it takes like a whole page. So to write the steps is not hard. Actually doing it is long.
That's one fine answer.
Yeah. Okay, so we need to know what row operations are. How do we change this so that we can read off the answer? Okay, so row operations. We can multiply or divide a row by a non-zero number. So just like we did before, multiply the row by -2 so that we can eliminate. So we can multiply or divide. You know, sometimes dividing by 10 will make the number smaller, right? You can do that. You can multiply or divide a row by a non-zero number. And you can add a multiple of one row to another. And 3, you can switch rows around. sometimes that'll make things easier. All right, so those are the row operations. You can multiply or divide a row, and you can add rows together. Basically, we're going to eliminate things by doing the same thing we did with just elimination. The only difference is we don't have the X, the Y, the Z. We don't have to keep writing those over, and they're staying organized, so we're not losing track of what we're doing, okay? So the Gauss-Jordan procedure is this. You're going to make a 1 in the top left corner. To make a 1, divide that row by whatever number is in the place you want the 1. So what that looks like so it says make a 1 in the top left corner, so that's right here. Put a little square around anything you want to be 1. Okay, this is row 1, this is row 2, and this is row 3. Okay, so that would be the abbreviation for those rows. Does that make sense? There's 3 rows here. So to make a 1, it says divide by whatever number's there. So what number is in the spot I want to be a 1? A 2. So I divide. So you show that over here. You say, okay, row 1 is going to equal row 1 divided by 2. So this is kind of like saying the new row 1. I'm going to rewrite the matrix by dividing the old row 1 by 2. So that's just dividing that row by 2. So this would be a 1, this would be 5 over 2, this would be 5 over 2, and 36 divided by 2, 18. So that would be step 1. That anytime you want to make a 1, we're going to divide by wherever the 1 is that you want, okay? We actually have to make a 1 for the X, a 1 for the Y, and 1 for the Z, but not all at once. And that's basically how we're going to do the elimination. If we only have one left, one X left, and no other X's, then we're going to be able to see what the answer is for the X's. Then we're going to have one Y left, but no other Y's, and then we're going to have one Z left and no other Z's. This is like your X, your Y, your Z. Okay, so that's step 1. Step 2 is to eliminate all the other numbers in that column. So step 2, we are going to eliminate all other non-zero numbers in the first column. That is, make all the other numbers into zeros. And that would be eliminated them. When they're 0 instead of 2 and 4, we're going to make those 2 into zeros. So you make a 1, and then we're going to make zeros everywhere else in that column. So how do you make zeros? No, because we're not going to change that row. We're going to only do the other ones. Yeah.
You can do whatever you want.
No, we're leaving the 1, because we want that 1 there. We're actually eliminating the other 2.
Okay.
Think about when we did elimination back here. When we eliminated it, it didn't,
But it multiplied everything in the row by
Yeah.
what you're doing. Yeah.
yeah, but that's just like a disguise. It doesn't, it's still the same equation. Like if you multiply an equation by 2, the same answers still work. Like if I had my x plus y equals 4, if I do 2x plus 2y equals 8, these are identical equations. They're not different. All the same exact points work. 2 and 2 will give me 8. 3 and 1 will give me 8. The answers that work in this one will work in this one. It's still the same equation. Yeah. So by multiplying an equation by a number, you don't actually change it. We're not going to change that row. We're going to leave it like that for now. And we're going to eliminate the 2 and the 4. Okay, so to make a 0.
Oh, I was thinking like you were going to change the 5 over 2 to 0. You know what I mean?
Yeah, they are later going to be changed to zeros, but not
Okay.
yet. To make a 0, you multiply the 1, right, the one that we just made, the one that's going to stay there. It's actually called the lead 1, or pivot. We're pivoting around it. That's a computer word for it. Okay, we multiply the 1 by the number we want to be 0, but with the opposite sign. Right, so what we're doing essentially is, if we want to eliminate the x, we're multiplying this by -2, the same number that's there, but with the opposite sign. Then we're going to add them together. So that is the same step, it's just going to keep it more organized in a matrix. Then add the 2 rows together. So let me show you what it looks like. Okay, so this is our 1 that's going to stay 1. That's called our pivot. Okay, we're pivoting around the 1. So we want these 2 numbers to be 0, because we only want to have 1x left. We want to eliminate all the other x's in the question. Okay, so to do that, we're going to do 1 at a time. So if we do this first one, okay, so that's in row 2, so just write a little row 2 over here. We're going to make a new row 2, and the new row 2 is going to have a 0 there instead. Okay, so what number is there? A 2. Ignoring row 3, it has nothing to do with it. We want this to be the same number but the opposite sign. So when we add it together, it becomes 0. So that's a 2, so what does the 1 need to be? -2, same number, opposite sign. So we're going to do -2 times row 1, -2 times row 1, and then add it to row 2. So it's the 2, because that was a 2, so we want the 1 to be a -2. And you can just do that over here. So this will be -2 times row 1. So multiply all of row 1 by -2. Kind of back to where we started, but we're not going to use this, just to find the 0. Zero, -1, -1, 0. So I multiplied everything in row 1 by -2. was easy because we just divided by 2. I just kind of went back to where we started and changed the signs. And then I wrote 2 underneath it and added it. Now, I didn't leave a lot of room, and you may not have left room here, but we want to do the 4 now. So this is in row 3, and it's a 4, so what does the 1 need to be? -4. So -4 times, what row is that in? Row 1. -4 times row 1 plus, we're ignoring row 2 because we're just using row 1 and row 3. So to make the 0, you use the lead 1, multiply it by the same number, opposite sign, and then you add those 2 rows together, ignoring any other rows. If there was 5 rows, you'd ignore all the rest of the rows. You just look at 2. So if we do this, -4 row 1, -4, you could do this on your calculator. I'm just going to multiply this one by 2.
You do that with the new R1, right? Like you don't use your original number, you use 5 over 2.
Yeah.
And 1, okay.
Yeah.
Alright. That was the whole point of making it. Oh, yeah.
And -4 times 180, 720. And we're adding that to row 3. Okay. So now I have my 2 new rows that I'm going to rewrite, and they have a 0 in that first spot. So 0, -1, -1, 0, and this one 0, -7, -4, -360. Okay, so what did we do? We made a 1 by dividing whatever number was there. Then we used that 1 to make the zeros everywhere else. Okay, so, and then we basically, step 3 is to do the same thing in row 2, or in column 2, but where would we put the 1 instead, do you think? We're not going to put it at the top, because that's the one for this equation. We want now the middle one to be a 1. That's going to be your 1 for your y. This was your 1 for your x. So what we want to do now, so we're going to say step 3, and on, basically, is you're going to make a lead 1, or a pivot, in row 2. The first non-zero number in row 2 needs to be a 1. Then make zeros everywhere else in that column. So you make a 1, and then you use the 1 to make the zeros everywhere else. So all the other numbers will be 0. And then what do you think step 4 would be? Make a lead 1. You're right. Make a lead 1 in row 3. And zeros everywhere else in that column. Everywhere else in that column. All right, and we're going to do that without a bunch of words now. I'm just going to write that matrix that we have. Okay, so what we did so far, we made a 1 and then zeros everywhere else. Then you go to row 2, and the first number you come to, you make into a 1. It's a negative 1. So, change all the signs, right? You divide or multiply the whole row by negative 1. So row 2 is going to be minus row 2. Does that make sense? Like dividing by negative 1 is the same as multiplying by negative 1? Or just changing all the signs? In fact, if I were doing this, I would just change all the signs, not rewrite the whole thing. I would just change these into pluses.
But essentially you're saying R2 times negative.
Mm-hmm. 0, 1, 1, 0. Okay. So we made the 1, that's called the pivot. And so now we want to make zeros above and below that. I'm going to do the two in different colors so you can see which was which. So above, that's row 1 that we want to change. What is in the spot in row 1? You could write that as a decimal. You could do 2.5 if you like that better than fractions. There's a 5/2 there, right?
Oh, so what are we doing? We're
Making this into a 0.
Okay.
I said you could write them as decimals if you prefer. It wouldn't really matter. Okay, so to make a 0, you use the 1. So whatever number is here that we wanted to be a 0, the 1 has to be the same number with the opposite sign. So that's a 5/2, so the 1 needs to be a negative 5/2. So negative 5/2 times row 2, because the lead 1 is in row 2, and then we add it together, plus row 1. That was a 5/2, we needed it to be a 0, same number, opposite sign. So you would do that step over to the side. 0 minus 5/2. I just multiplied minus 5/2 times row 2. And then we're going to add that to row 1. Interesting. 1, 0, 0, 180. I'm not changing row 2. That was the one with the pivot in it. But that was my new row 1 with the 0 in the right spot. Okay, so now this 7. I don't want to write that row yet because I want a 0 to be there too. That's in row 3. This is a negative 7, so what does the 1 need to be? Positive 7, right. So 7 times row 2, and then add it to row 3. So we want that to be 7, and then we add them together. So 7 times row 2, plus row 3, zero, 0, 3, negative 360. Okay, so what did we do? We made a 1 and then zeros. We went here, we made a 1 and then zeros. Then we go to row 3 and we make a 1 right here. So that there's a lead 1 in each row. So that 3 needs to be a 1. To make a 1, you divide by whatever number's there. So this is row 3, we're going to divide it by 3. 360 divided by 3, 120. Lots of ones and zeros now, but there is still one more number we need to change. Do you see which one it is? So we made a 1 and zeros. That's good. We made a 1 and then zeros. We made a 1. They need to be 0. This one already is, so that's good. That's one less step. But this needs to be a 0. All right, so whenever you make a 1, you look up and down in that column. Any numbers that are there, you have to make into a 0. This is in row 2 that we want to be a 0.
Where did the negative 120 come from? Why did you divide, oh, you were just making it into a 1?
Right. So you divide that row by 3. To make a 1, you divide by whatever number's there.
This is very different.
It gets really easy.
Okay.
Because you're always going to do the same thing, but the first one I find really confusing. The second one you start to say, oh, okay, I get it. And the third one you'll be able to do. Then they get more complicated because there's different types of answers you can get, but we're going to stick with the kind of easy ones to start. But you can make an easy adding mistake and then screw up the whole thing, so you do have to be careful. Even though it's not hard, you can make a mistake. But the good thing about it is you can check your answer in the end into the original equations, and if it works, you know you did it all right. And if it doesn't, well, it actually works out okay. If you plug it in and it works in the first equation, good. It works in the second equation, good. And it doesn't work in the third equation, it means you've just made a mistake in this last column. But if your mistake is, if it doesn't work in the first equation, you just start over again. Because even if you find your mistake early on, it would change everything, right? So then you'd have to redo it anyway. But if it's in the last equation, that sometimes happens. You make a mistake at the very end, then you can find it usually. Okay, so this is a 1. This is a little bit confusing, but we want this one that I have circled to be the 0. That's in row 2. It's a positive 1, so the 1 down here needs to be a negative 1. Same number. Negative times row 3, whatever the pivot is, you multiply, and then you add to row 2. These are always the same. The row you're changing and the row you add. Right, the row you're changing and the row you add, the row you're changing and the row you add. That's always the same. The one in the middle is wherever your 1 is that's going to stay. So minus row 3 plus row 2 0, 1, 0, 120. This doesn't make sense. Can't have a negative answer because this is a word problem, right? It might be the problem that's set up wrong, not the, I maybe when I made the question didn't intend on actually solving it. So we're going to pretend it's okay. We'll check our answer.
Where did the negative 120 come from?
I just rewrote that row. I just changed, the only row I changed right now is row 2. The other 2 are just the copies. What I'm saying is it's a word problem and we have a negative answer, so we're going to still check it in the equations. Right. It might just be that the word problem was not meant to be solved, or maybe I typed something wrong. But we'll check it. I don't think we made a mistake because I did it all very carefully. I think no one said you added those wrong or anything. So, okay. So this is your X, your Y, and your Z right here, right? Remember when we put them in, those were the X, Y, Zs, kind of like your table, and there's your equal sign. But all we have left now in the top row is what? 1X. Right, X equals 180. And then in the second row, we have Y. 1Y is equal to 120.
Oh, that's what you mean by redocumenting.
Yep. And then here we have Z equals negative 120, which, again, either we made a mistake or the question's faulty. Okay, so how do we check our answer? The equations. So let's look what the equations were. I just wrote the matrix down. Oh no, there's the equation. So 2x plus 5y plus 5z equals 360. I'm just going to leave a space and then I can plug them in. Okay. So 2 times 180 plus 5 times 120 plus 5 times negative 120 equals 360. I can see already that that works. So far so good. It worked in the first equation. That means if there's a mistake, it's not early on. That also works. Do that one in my head, but it also worked. Yeah, so it was a question that was faulty. Like, we'll pretend this didn't come from a word problem. Okay. Which really doesn't matter. The textbook ones will always work out because they've probably checked them, right? So, yeah. But again, you're going to solve a system separate from word problem anyway. You'll set up the word problem equations and then solve. But it works in all three, so we got the right answer. We're just not going to...
What would the meaning of that be? It would be like...
Well, what was that word problem anyway?
Number of dining rooms, so you'd have to make negative 100.
Yeah, that doesn't make sense, right?
No, I'm just curious.
But let's say it was, 180, 120, 120, say it worked to normal numbers. Then you would answer 180 coffee tables, 100 whatever.
Yeah.
They were chairs, coffee tables, dining room tables, yeah. I don't think, was that one from there? Yeah. What's probably wrong is the 360, 360, 360. Probably one of them wasn't supposed to be the same as the others when I typed the question,
Maybe the third one. I guess it's...
Yeah, and it usually works that way. Okay, so we're going to stop. I would not bother doing anything until Tuesday. You can go and look at them if you want. Try setting up a few problems, but don't do the solving until I do a couple more examples, okay? We have lots of time. We have 5 classes. We're going to finish the solving of these next class. We'll do a whole bunch, and then trying them after that would be your better bet, okay? If you want, I didn't make up homework. I forgot. So, so if you want to do something, because this is Thursday, we're not back till Tuesday, so if you want to look at something, go to the questions. I'll make sure they're posted tomorrow. And I've got a bunch of set up these word problems. Try those ones, right, to set up, because we're not setting any more of these up.
Actually,
But the solving will do.
When you do